are the Borromean rings. So these have a special property in that, for example, if you look at this red circle and this green circle and ignore the blue circle, then you can just remove them because they're just like this. You can remove them. And actually this holds if you remove any of this. So if you ignore the red circle, then you could remove the blue and the green. And if you ignore the green circle, then you can remove the other two. But you cannot remove anything if you have all the three at the same time. This is an interesting property of this configuration. But what I want to show is that this diagram cannot happen in real life. So what does this mean? So they are depicted as circles, but I want to show that, I want to assert that you cannot actually find three circles in space which have this property exactly. So you could draw it if you have, for example, ellipses. So this is sort of a actual drawing in 3D with ellipses, but you cannot draw it with circles. So I wanted to talk about this, but I'm not sure how far, what I should talk about at the moment with only about a few minutes remaining. But so I want to maybe talk about this in 2D. So an analog of a circle in 2D, in 1D is, in 0 dimension, because circles are one-dimensional objects. So they have like one perimeter. But in 0 dimension, a circle is just 2 points. And you could define when whether two circles are interlocked. So for example, these circles are interlocked, but these two circles on this line are not, because you can remove them. So the thing I want to say is that you don't stay on this line, but you stay, you introduce one more dimension and you draw the circles associated to them, actually half circles, have arcs. Then I will say that these two circles, these two 0-dimensional circles, are interlocked if and only if these two arcs intersect. Well, for example, these two don't intersect, but these two. Well, this is maybe kind of intuitive. Oh, sorry. I should probably clarify that these two circles are considered not interlocked in some sense. But so if you think of these in maybe that was a bad example, but so what I actually want to say is the same thing, but in 3 dimensions. So you have these circles in 3 dimensions, and I want to say that these configurations are interlocked if and only if you introduce a new dimension, the 4th dimension, and consider these hemispheres. And then if the hemispheres intersect, then it exactly means that they interlock. But if they don't, it exactly means that they don't interlock, and you can separate all of these circles. So I hope this talk was interesting, and I think I should finish now. Thank you for listening. So maybe we could do a Q&A session.
Yes.
How
if
does
anyone
this work,
is,
Mark?
Yes. I know we're slightly over time and many of you
Oh,
have to go somewhere else, but if you have any questions, go ahead and ask them now. Does anyone have any questions?